Today, Open Source Security is talking to Andrew Nesbitt, open source developer and package manager nerd. Andrew runs my absolute favorite project in the whole world. It's called Ecosystems, but it's Ecosyste.ms. Hopefully I didn't miss a letter. But Andrew, welcome, man. I'm so excited.
Thanks for having me. I'm a long-time listener, first-time caller.
well, and I feel like I've been talking about ecosystems to people like forever. And I think this is the first time you've been on the show, which is like, holy cow, that's wild. But yeah, I mean, I'm so excited. Okay, so let's just start out. Tell us what Ecosystems is, and we'll go from there.
Okay, so Ecosystems is primarily a index of open source metadata for all different kinds of objects and data types that you would find in the world of open source software. So that's things like packages and versions and dependencies and repositories and commits and issues and pull requests, and the long tail of things goes on for a long way. But the really interesting bits are in the data around the packages from many different package managers, all of the versions, all of the dependencies, and then the repositories from all of the different Git hosts that exist. Obviously, GitHub is massive, but there are lots of other smaller ones as well. Some of them are very active, especially kind of the ones that the Linux distros use. They often have a GitLab or a Git instance. And then I mine the dependencies out of all of those repositories as well, so that I can connect them back to the packages data to get kind of my first use case was I want to be able to show which of these packages are the most used and the most critical. And the way that I approached that was to try and find every user of every package, at least in the world of open source, right? Every public repo. So the only way to do that is to mine the dependencies of everything that you can find.
Yeah, it's an absolutely phenomenal data set. Before I hit record, you mentioned how big the data set was. How big is it all right now?
So the biggest database is about 3.5, maybe 4 terabytes.
Wow.
And then there are smaller ones, but they end up with kind of around 5 terabytes of Postgres data, not really including the indexes. Some of those indexes could get pretty chunky.
Yeah.
And the biggest table has 22 billion rows in it, which is the repository dependencies table.
That's amazing. I mean, holy cow, that's crazy. And so I love your data because I am always very interested. So I worked at Elastic for a long time, and I love just looking at graphs of things and trying to connect dots and data. And I remember I used to pull down the NPM data straight from NPM, and it was a tire fire because NPM's data didn't necessarily have anything resembling normality for a long time. And the new stuff is better, but getting through the old stuff is terrible. And I remember someone showed me your API, and it made my life so much easier because you've normalized all this data and you've made it very consumable, which is amazing. And the API is open, so anyone can use it, which is fantastic.
Yeah, I wanted to try and have some kind of schema that was the same for every package manager. Like as I went digging, if you find the same patterns in every package manager, the implementations are slightly different, and some of them might miss some features off, or some of them might have some extra bits and pieces, but they're generally very similar: packages, versions, dependencies, and then registries as well, being the kind of the high level object that ends up being very similar as well. Some ecosystems have multiple registries, but many in the kind of the language world have one primary one that is public, and it's fairly easy. The thing you run into is like if you use npm, you get that changes feed, which is looks like a CouchDB interface. It's no longer CouchDB. It's Postgres pretending to be CouchDB under the hood. But at least you can kind of say, oh, I'm going to stream all the new versions that come through. And then they have one document which contains all the versions and all the metadata for each package. But then you try and transfer that, any scripts you've got or code that is working with an API like that to a different registry, and you instantly run into, oh, they don't have a changes feed. Their RSS feed of new packages contains 10 items.
Right.
I'm going to have to poll all of this all the time. How do I get a list of all of the names of all of the packages to go and start fetching the list of versions for each one of these things? Is like, oh, this is terrible. And some registries have like, a JSON or an XML API to be able to say, give me the list of names and give me the list of versions for a thing. And some of them have none of that. There are package managers that are just like, this exists on GitHub somewhere, and until someone else uses this package as a dependency, it doesn't count as a package. So there are a couple of Objective-C package managers that I have where any repo can be defined as a package on that thing, but it basically only ends up in the database if someone else declares it as a dependency.
Lovely. I mean, you could do that with Python now, which is, it's very cool because I can just like point it at some random repo I have that I use as one of my own personal like dependencies. But yeah, it's madness, man. It's so complicated.
You have package managers like the R package manager that doesn't have any kind of API. It just has HTML. So you have to scrape some pretty old, janky HTML. There was one package manager, the Wasm one. I don't know if it still exists anymore, but it had a GraphQL API, which was an experience. Of course, you have absolutely no ability to cache anything with something like that. So when I wanted to do any of this, I was like, I need something in a normalized format. Of course, you run into like, oh, it's not just the APIs that are different, but sometimes the data is. The classic one I like to point to is that you would think NPM package names are case insensitive.
Nope.
And at some point they changed it to be like, oh yes, this should be true, but they never removed the old like first 1,000 case sensitively named packages. So you might make your database index be like, oh, case insensitive unique on package name. And then you would put the first few in and be like, oh, why are these things still here? They've not been published. They're not allowed to be published anymore. But they've not been removed.
Yes, no, and NPM is like the worst at that. All that old data is just weird, and because it's just JSON, you get back an arbitrary blob of crap. And I mean, when I was
there's very little in terms of schema there, right? Because CouchDB again, your Postgres is pretending to be CouchDB still, and so it's like there's no columns here. It's just big chunks of JSON.
Yep. I don't even want to know how they pull that off. But anyway. Okay. So I want to, before we get too far into it, I want to also mention that this is like Ecosystems is an open source project, right? This isn't like some company funding this, and you're part of the Open Collective for your funding, right?
So the project is physically hosted on Open Collective. So we have a collective.
Okay.
And that's how the project first got started. We had a grant from Plaintext Group, which is part of the Schmidt Foundation, to kind of stand the project up. That grant went to Open Collective, or it went to Open Collective Foundation, which is no longer a thing, but it was for a while. And then that kind of got the project kind of stood up and working in a good state. And then Open Collective basically have been using it and been contracting me to build tools on top of the base data. So Ecosystems kind of core services provides a load of base data for anyone to build on. And then I'm building tools for Open Collective to give you kind of insights into the projects that are hosted on Open Collective or how different projects are funded. And they are contracting me to do that, as well as providing some maintenance. And then I have a few paying customers that pay for a different license for the data, so that all the data that you fetch from the API is Creative Commons share alike. And you can basically pay for a yearly license to get a CC0, and then you no longer have to kind of share any of that data or even attribute it back to ecosystems. Whereas if you're using that data, then you should be like saying, oh, this came from ecosystems, and the transformations we did from it are under the same license. So kind of like a copyleft, but for data.
Right, sure. And as like a normal person, you can also donate as well, which I know I think I donate $10 a month to ecosystems just because like I've written,
yes, it's very appreciated.
I've written so many talks and blogs about your data. It's like it'd be horrifying if I wasn't doing something.
The project is designed to be very low cost in terms of the infrastructure. So it's basically read only from all of the API points of view. You can't.
Yeah.
It doesn't have to worry about lots of state in the kind of requests. Everyone is getting the same data back, and then Cloudflare acts as a caching layer. I think it's serving. Last time I looked, it was 1.1 billion HTTP requests a month.
Wow.
Which is approximately 80% cache hits. So that means I'm, only serving a fraction of that requests, and that keeps everything cheap, right? It was designed so that if I'd done the same thing on AWS, you could imagine the bill being much bigger.
Yes, for sure. Okay, so I have so many questions, and there's so much I want to talk about. But okay, let's just kind of start with, I want to talk about the numbers, because I think people don't understand how big open source is. And the poster child I use for this is there's an OpenSSF issue. It's in the TAC. It's like issue 101. I can't remember. I'll go dig it up and put it in the show notes. But there was a point where there was this discussion amongst the OpenSSF TAC members. I was a member of the TAC as Technical Advisory Council. I was a member of the TAC at the time. And someone was basically like, oh, most open source is multiple developers. We should have rules around how many developers is like the right number. And I remember I'm like, I have this data. Like, I know, I have the answer. And I'm like, it's one. Like, the answer is one. And when you look at the graph, it's like, it's horrifying how much open source is literally a single person. Like, but this is the thing I don't think people understand. So I just pulled up ecosystems, and this is the numbers you have listed on your website here. 11.4 million packages, which is a lot, right? And I know once you take the number of packages times the number of versions, you end up in it's like 110, 120 million now, I think. I haven't looked in a while.
Yeah, something like that. There's an average of 10 versions per package.
Yeah. Like it's enormous. And well, it's funny though, there's an average, but there are packages with thousands of versions, and most packages have one. Right? Like the reality is the vast majority of open source is one person, one package. And yes, most of it is not downloaded, like hardly ever. And we'll talk about that later. But you have 262 million repositories. Repositories, I assume, is GitHub repositories in this context? Or Git, I should say, not
Git
GitHub.
Repo. The caveat there is that I don't index uninteresting forks. So if a fork doesn't look like it has a commit or even like any stars on it, is quite a good indication that there's nothing going on with this repo. So I just don't bother, because it's just a duplicate of, often people will use the fork button like a bookmark.
Right. I do that all the time.
So that data isn't actually very interesting. But when GitHub says, oh, we got 1 billion repos, you're like, right, but how many of those are just a copy? And it's not even a full repo, right? It's just a branch that is under a different namespace in the same repo, really. So they haven't actually copied anything. It's just an extra database record. So I only index the things that are interesting in terms of the potential there. And because that data would be absolutely enormous to kind of duplicate a lot of those things. And I'm pretty sure no one is using most of those forks.
Right. And still, 262 million is a ridiculously huge number. Like, it's unthinkably large.
It is a headache to host that many in the repo service right now.
Yeah. Yes, absolutely. And the thing just as a side note, I'll say is, if 10 years ago you'd have told me you could host this with Postgres, I'd have been like, there's no way. Like, you're full of crap. because like that was when NoSQL was like becoming the big thing and you could host, hundreds of millions of things on your laptop and it worked fine and stuff like that. And like, I am impressed by how just versatile Postgres has become over the last probably decade or so, where like I know tons of people using it for massive data sets like this, and it does it no problem. It's amazing.
Yeah, it's a lot of my successes are built on top of Postgres, and being able to rely on it to kind of do loads of stuff that you don't even realize what's going on behind the scenes,
Yeah.
or like if it crashes, the work that it does to bring itself back to life is saved my bacon a number of times where it's like, oh, if this was Mongo, I might be in a bad place and have to recover from a backup, whereas Postgres is often like, oh, it's okay, just give me a few minutes, or if the database is, in the terabytes, give me 15 minutes. And then it comes back to life, and you're like, wow, that's great. Obviously, you need to design around it a little bit, but when you kind of know how to use it, it's a very powerful tool.
Yep, for sure. And I remember you sent me, I can't remember what dump. You sent me a Postgres dump at one point of some data, and I think it was like 300 gigs of data. And I remember I'm like, I don't know if I'm going to be able to do this in the house. Like I might need to go seek out, some cloud service or something. But I spun up Postgres in a VM. I gave it, I think, like 32 gigs of RAM, and I just started it. And like 2 hours later, it was all there. And I'm like, this is ridiculous. Like, holy cow.
Yeah. My dumps don't normally contain the indexes. So your work is, I need to create the indexes once I've inserted it. But then it comes back and it's pretty good. And then you can just run the app locally if you wanted to on top of that.
Yeah, and then I queried it like to death, and it was ridiculous. Like, anyway, okay, I want to keep going. You got 22 billion dependencies. What does that mean? 22 billion is a lot.
So that is, there's a row in the database for every link between a repository and a package that it says I have a dependency on, and that might come from one of many. I think I've support 100 different kinds of manifest or lock files. So that's your package JSON, your gem spec, and then many others, and then all of the lock file equivalents where appropriate. And then when there are multiple tools, like UV has its own lock file format, and many NPM alternatives have their own lock file format as well, then it supports those. And it basically then will go and look at each repo every time that it sees the repo has changed. So the commit on the main branch, and it will go, oh, I'll try and mine these dependencies again, and then store them in a nice way along with the version and any extra requirements that might kind of fit in there, which does give you the ability to then say, here is every repo that depends on a particular package, and here are the versions or the version range potentially that this pack allows you to basically get a breakdown of how many people are using old versions of a thing. And you see this a little bit in the GitHub dependency graph feature, but they don't make any of that public people scrape it. They scrape the HTML of GitHub against the terms of service to try and get that data out, because it's really juicy. You can kind of go from like security advisory with a version range that's affected to go and find every open source project that depends on the thing within that range, which then gives you a nice kind of list of, here's the most critical projects that need to be updated, or need to be patched to make sure that they are able to pick up a new version that doesn't have that vulnerability anymore.
Yeah. And I mean, this is one of the things I think that is most interesting with your data is that point of like, what are like the critical packages everyone is using? I mean, I think left pad some years back was like a shock to everyone that like the internet broke when the developer removed left pad, and everyone's like, what the hell?
I mean,
what the hell's left
pad? The shock there was that NPM let you just yank packages. It wasn't that someone had done it. It was that a package manager that big and that like much infrastructure allowed you to just pull a package. Like in the early days, NPM let you force push a version. So you could just replace the code on a given version number, and that would just like absolutely not fly today in many setups, because you're like, oh, well, someone overtook this, and rather than just publishing a new malicious version, they republished every existing version as well, which would be like, oh god, what are we doing here? We can't even rely on the version numbers to point to the same thing that we expect.
Yep. Oh, it was wild back then, man. Like, it was wild. Anyway, okay, and then the last thing you list is 1.7 million maintainers, which is a lot of freaking open source contributors.
Yeah, and that is a maintainer. I actually changed the word of that like 2 days ago, because it used to say developers, but the maintainer is someone who is able to push a new version, as far as I can tell. So not every registry has a concept of a maintainer in its API and its dataset.
Yeah.
Especially things like Go, which isn't really a registry at all. It's just a proxy server to many Git repos.
Yep.
But if it's on Ruby gems, then you can say, oh, these people are declared as kind of an owner of the gem, and therefore are able to push a new version of the gem or do other kinds of admin-y things at the publish level rather than at the source. So I do index committers and you can get some interesting data, at least from GitHub. I'm not sure if you can get it from Codeberg and GitLab yet, but if you go looking at issues and pull requests in a repo, the person who's opened those gets like a little label to say what their role is on that repository.
Yeah.
That lets you then work out, do these maintainers belong to this organization? Like, which ones have the commit bit or the merge access on these repositories? So you can then kind of go, okay, well, I've got a good idea of who is an active maintainer of the repository, as well as who can publish to a package manager. I mean, if you've got the kind of GitHub Actions auto publish setup, then the merge is the publish, because there's a bot that will do the actual publishing for you.
Yeah.
But kind of spelunking there lets you kind of go, okay, well, we can find who looks like is a real maintainer, even if they don't publicly say they belong to this org. Then their activity in the issues and pull requests shows that they are. It might seem like it's hidden, but it's all very, very public, and very anyone who's malicious can kind of go and work out, like, you look like you have the commit bit to this project because you've got little flags on every comment that you leave on every pull request that says, I am a contributor or a collaborator.
Okay, and that's fair. And so I guess in that context, the word developer would be defined as like anyone who's contributed code at any point, like even if it's a one-line pull request.
Maybe also opened issues or pull requests, even if they didn't get merged, you could kind of say, oh, they have contributed. And I'd say of all of the kind of active projects, I've maybe got there's probably 6 million open source developers that are active across, all of these different, especially like the repositories that are linked to packages rather than just, and then, all of the owners of those things come out to be something like 5 million, which is orgs as well. But there's a lot less orgs than there are maintainers. Again, those numbers seem big, but they're a lot lower than, when GitHub says, oh, we've got 100 million developers. And it's like, but not all of them do anything on open source.
Right. And I mean, that's fair. And look, we all know that the numbers marketing releases are not the numbers anyone else would release in any way. And that's okay. I understand they have their job to do. And okay, so these are mammoth numbers. And I feel like we as humans cannot comprehend like what this scale even looks like sometimes. Like we're humans are 1, 2, 3 more than 3. And you are working on a scale that is just unimaginable sometimes, I think.
Yeah, but I don't personally keep track of any of it. I've set up systems that will go through and will sweep and pick up and update these things on a regular basis.
Sure.
The bits that I do keep an eye on are what I would call critical packages. So there's a flag that I put in the API, which is like Andrew's definition of this package is critical within this ecosystem. There's lots of kind of like, you get the raw data and then you get like, here's Andrew's kind of various automated ways of flagging certain projects as certain things, so that you probably end up implementing that kind of same thing yourself. In terms of critical, that's basically so come from the idea of kind of 80-20 rule, 20% of people are doing 80% of the work. In this case, you would think it's like 20% of the packages in a given registry are being used, compared to the 80% that aren't really, the long tail of packages that never get used. It's not 80-20. It's like 0.1 or 0.01 to 99.99. Like the steepness of, what's the opposite of the long tail? The like fat head or short head?
Yeah, I don't know, but I know what you mean. Yeah.
Of that graph is so steep. And so what I do is I get the sum of all the downloads, or if the registry doesn't provide downloads, then I'll use the dependent repos count, which is, the total number of open source repos that depend on a thing, which is a nice fill-in for like Go and other registries that don't provide download counts.
Yeah.
To be able to say, I start from the top and just start summing as I go down, and then I stop once I've reached 80% of all of the downloads were for these packages. And for most registries, that is less than 1,000 packages total. Even in a registry of 1 million things, you end up with like, there are 1,000 Rust packages out of the million or 1.1 million Rust packages. There's 1,000 that are downloaded. 80% of all downloads are of those packages. That basically gives you a pointer to say these are the critical packages. Like if anything happens to any of these, everyone is going to have a bad time. If you're below that, then the blast radius is much lower in terms of open source, right? And it's not necessarily always exactly the same mapping between closed source usage and open source usage, but open source usage is so big that you can definitely draw some parallels there to say, like, we're pretty sure that if everyone is using this in open source, they're probably also using this in closed source.
It. Yeah.
The things that are like the kind of like authentication protocols that enterprises use, those things don't look like they have any open source usage. Or A/B testing libraries. No one puts A/B testing libraries in open source projects, right? They don't have the time to, or any kind of financial incentive to fiddle with the different views. They're like, we can barely maintain one view, let alone make 5 and do a multi-arm bandit test to see which one generates the most sales on our free and open source platform.
Right, exactly. Okay, you just said the word blast radius, and I've been waiting to get here for a while. That was my next question. So, no, this is super interesting, though. This is something you've talked about a little bit in the past, and I've honestly not done a good job of paying attention to if you've done anything with it in the data lately, but you have this concept you call blast radius where, and I think a good example of it is something like, let's pick on XZ, right? Where there was a backdoor inserted to XZ, and the blast radius being all of the things using XZ that would then potentially be infected by, some sort of malware, some bad thing, a security vulnerability, a rogue maintainer, backdoors, whatever. And so, like, explain this concept to us. And you are like the only person I know of that can actually create this sort of data, at least in the open. I'm sure there's some secret data sets.
There's definitely people that do this with secret, like, especially kind of network logs, I guess, where they're looking for certain kinds of usages of attacks against servers. But in terms of and these numbers, they do get a bit fluffy, but again, like, the scale of them is useful in kind of the moving towards statistical significance, that rather than just saying like, oh, we've got a vulnerability in a package and saying like this vulnerability is really bad, then being able to extrapolate to how many open source repositories and other packages depend upon this this package in this vulnerable this vulnerable version can be in the millions. And because I collect both the transitive dependencies and the direct dependencies, you can then in open source, you can actually point to say like, oh, all of these projects, all of these Git repos have this package with this vulnerability, and it works great if you don't have a patched version yet, because you're like, you're definitely vulnerable. Doesn't necessarily mean that you're on the, your implementation actually touches that hot path of vulnerability. All kinds of like edge cases there, but in terms of the kind of like extrapolation of the percentage of projects that could be affected by this vulnerability being out in the wild, is like we just multiply the number of dependent open source projects by the severity of the vulnerability on the package. So if this is one of those critical Rust projects, you're like, oh, this could have an effect on 100,000 other Rust projects. Is there 100,000 other Rust projects that are actually in the wild? I don't know, but there's certainly a lot of toy projects. But then like that works across every different ecosystem as well, right? So you're able to get a feel for like how impactful could this be potentially, as well as prioritization, right? You look at these numbers and they're enormous, and it's like there's no way we can possibly look at everything and fix every, like we could try and get Dependabot to open a pull request to everyone, but lots of those projects are like, we really don't want to see Dependabot right now. Being able to prioritize and say, well, we know that these projects are really critical and they've been caught in the, like, they have a transitive dependency on this other thing, well, then we can prioritize like going to see how that gets affected by maybe even just testing against the new version of a thing. If you're going to have to do a breaking change to fix your security vulnerability, you can then go, well, does this breaking change affect these other critical packages that depend on this vulnerable package? As a way of kind of being effective in the small amount of people that are available to help with dealing with the fallout.
Yeah, for sure. And even as a person who deals with vulnerabilities in a commercial perspective, right, for the company I work for, if there is a vulnerability that affects one of my things and there's a vulnerability that affects all of my things, guess which one is going to get looked at first, right? I mean, this is one of the more interesting aspects, I think, of the kind of the data you have, and I'm very excited to see where this goes in the future. And we will talk about that again in the future. But I think for now, let's bring this one home, Andrew. I'll give you the floor. Like, tell us anything you might want to tell us about ecosystems or what you're up to, kind of how people can get involved, use a project, donate to the project, all that stuff.
Yeah. So. The thing I will say is that Ecosystems is all free to use. There's no API keys or anything right now. You can literally just start consuming data. Luckily, most of that will be shed up straight through Cloudflare and won't hit my servers. But there is a high buzz factor on the Ecosystems project right now. So if you are interested in getting involved and contributing, either through like just kicking the tires and giving feedback and suggesting new features or new data that you would like to see, or implementing some of those things, or if you want to wrangle terabytes of Postgres data, then there's always fun things to do there with DBA like tasks. It's all very old school, but it's there's a lot of potential for improvements. Or if you want to contribute financially, then we have the Open Collective project where you can donate, and that helps towards the server costs, and maybe eventually to pay someone else to contribute to the project in terms of maintenance and making sure that everything is running nice and fast. Because there's definitely some growing pains as it creaks, and AI bots just absolutely like smash everything to pieces, which is hard to turn off, right? Because then you got an open API. It's very hard to block people that without doing lots of introspection into what that user looks like, which then it costs in terms of servers to do that analysis. So there's lots of different ways that if you want to contribute, or if you just want to use it, and let me know what kind of cool things you've built with it, because I'm always really interested in seeing and that helps trigger more things in my brain to work out other ways that we can do cool experiments and build extra tools to help make open source better, because that's what the project is really about.
Yeah, for sure. For sure. I mean, I've learned a ton from it, and anyone who I talk to will tell you, I love showing these graphs off. So if you have a meeting with me, it's probably coming up at some point, and it's so much fun. It's just, yeah, Andrew, I mean, thank you for the hard work, man. This is one of my favorite projects in the world, and it's amazing. And I know how thankless open source can be. So thank you very much. It is amazing, amazing stuff.
Great. Well, I'm very happy to work on it. I'm happy that you enjoy it as well.
Awesome. Thank you much.